Fractions aren't exactly everyone's favorite part of math. Some things with fractions are easy, like multiplication. You can just multiply straight across. While some things are a little harder, like addition. Remember that you need common denominators. So, for fractions without common denominators, we need to do the whole, find the least common denominator, build each fraction thing. This is made only a little more difficult when you start talking about fractions with variables. The common denominators look more messy, but it's the same concept. You multiply each fraction by whatever it needs to make the denominators the same. I know, this is all old news, but there's still something kinda new that we can glean from this. Since these are all equations, they work in both directions. In addition to adding these fractions together to make a single fraction, you can also split up a fraction to make multiple smaller fractions. This is called partial fraction decomposition. We are breaking down, or decomposing, a fraction into smaller parts. And we sometimes have reason to do so. Say if I were to integrate this big fraction, it'd be easier if it were written like this. So, how do we go about this? Let's try to look at our work so far and get some info out of it first. A big thing I notice right away, looking at this, is that the denominators of our original fractions turned into the factors of our big fraction. Let's try using that fact on this fraction. Because of that factors in the denominator thing, I'm focusing on the denominator of this fraction first. It's not factored yet, so let's factor the denominator. It looks like factoring by grouping might work. Once we've done that, we can speculate on what the smaller fractions are going to look like. Their denominators, at least. Finding exactly what goes in those numerators is actually most of the work of performing partial fraction decomposition. First, we know that they are some kind of polynomial. We're not going to see a random sine function pop in or anything. We can also say that the degree of the numerator has to be smaller than the degree of the denominator in each fraction. That's because if the degree on the top were bigger, or equal, you could use polynomial long division and just end up with a smaller fraction anyways. This should be enough for us to get started. Since it's equal to the original fraction, we can treat it like it's an equation that we're solving. As much as we love fractions, we should probably remove them in this equation by multiplying by the original denominator. Here's where you'll have to trust me a little bit, since we're going to do some weirder stuff. First, simplify the right side. Then, combine like terms. This basically means we'll factor every like power of x, so all the x squareds should go together, for instance. Now, equations are very strong statements, and they work on polynomials like this. These two polynomials, because they're equal, are exactly the same. What that means for us is that the coefficients on both sides are equal. So, the thing in front of x squared on the left side has to be equal to the thing in front of x squared on the right side. You can say the same thing about every power here, including the constant term. Even though it doesn't come up here, note that when a power is missing from one side, its coefficient is just 0. This effectively just makes a system of equations that you can solve using techniques like substitution or elimination. This can take a good deal of work, so feel free to pause to make sure you understand every step. Once you've found all of the coefficients, good news, you're basically done. All that's left to do is rewrite your original fraction, since that's what we were trying to do in the first place. Since it's a good idea to check your work when you have time, let me show you a couple of ways of doing that. If you have a graphing calculator handy, a quick and dirty way of checking your work is to just graph both functions. If they line up, they're probably the same. Another way is to just add them back together. Remember, this whole process is the reverse of a more familiar process, so just do that. See where you end up. Partial fraction decomposition uses a whole bunch of skills you've probably touched at some point in the past. So I recommend just trying some problems from start to finish to make sure that you have everything down. Hope this helped. Bye!